Okay, all right. What? Homework we do Wednesday.
Can we go in front of the camera?
No. All right, here we go. Let's kind of talk through some stuff. Okay.
No.
All right, hey, let's take a seat.
Yeah.
I'm recording class, make sure you're ready to go. Okay. All right, 8-1, the things I want to talk about today, the goals. We have new notes today. Now I know yesterday we spent a lot of time talking about radicals and roots. That is still a part of the homework. That's why I've been spending so much time doing that. We're going to do one example of it, not multiple. One example of a radical. Something that I've shown you all week, but I've never actually did the problem yet, which is kind of funny. So I'm going to do it today. We're going to review Theorem 8.1 really quick because that's the setup for our two new ones today. These theorems, I know they're going to be complicated and hard. When you actually read them, it'll be kind of confusing on what it's trying to ask you for. Once you have it written down, then I'll give you the formula, because it tries to explain in words what the formula is. It does a terrible job of it. I will give you the formula. Then we're going to do two examples of each type, so you know how to use it, because it's ridiculously easy when you see somebody do it. But just reading the words, it's like, God, this is hard. Until you see somebody doing it, you're like, oh, it's junior high math problem. Okay? And I'm not joking, they're easy. Now, they will tie in radicals and roots. The last thing, because these two theorems have a similar word in them, they have the word geometric mean. I will talk about what that word means today, but I won't go full in depth until Monday. Okay? So, this is kind of our outline today. It's going to go really fast. You'll have about 10 minutes at the end of class day if I kind of move along here. You will have new homework today. It will be due Wednesday next week. That is the 7th. So be aware of that. I will give you time Monday and Tuesday to work. But now remember this. Monday, Tuesday, Wednesday, we're moving on to different notes. So we're going on to the next sections of Chapter 8, the two sections I need to cover. We will have homework at some point next week at one of the days. But just kind of be aware of that even though I'm going to give you some time Monday, we are moving on to new notes each of those days. I said tentatively at the end of the week, I was going to kind of start trying to review, and that's still kind of the plan. By the end of some point next week, Thursday, Friday time frame, I want to start reviewing for the next test we have. Okay, so the test will be the following week, some point during the week when I feel like we can do it. But we'll get to that point later. Okay, so here's the first part, radicals and roots. There's different types of radicals, right? Square roots, cube roots, and so on and so forth. Today's focus is on square roots. That's the only problems that are in the homework, square roots. Certain problems you can simplify by hand. There's certain problems you'll need a calculator. That's why I've been so adamant about getting mine back. I'll explain when you should do one versus the other. Okay? So that's kind of the goal today. All right. Now, vocab terms. We have a bunch of new words today. We have radical sign, radicand, and index number. We still need to know how that works today for the notes. When we actually get to this part today in the actual problems, I'll kind of explain, but this is the problem I've been showing you all week. The funny thing is, I've never actually simplified this problem yet. I've shown you the picture all week, but we never actually did it. I want to talk about it today. Now, this one does have a cube root. It has a 3 in it. Yours won't today, but it uses the same rules, right? So when you have a radical, that's not a decimal in here, right? That's a nice clean number on the inside. That's called a radicand. This is the number that you're breaking down. And again, when you break it down, you're just breaking it down to two numbers that multiply to give you 8. So what can 8 break down into?
4 and 2.
Yeah, 4 and 2. Don't worry about getting to triples. Don't worry about that. Just break it down into two numbers, and if it can go further, keep going. Like the 4, this can break down further.
2 and 2.
2 and 2. Now, don't lose track of the other numbers. That's something that a lot of people were doing yesterday by accident. They were losing track of numbers. Draw arrows if you need to keep track. So now that I have that, that does have a triplet, which is what we're looking for, right? It's a cube rule. So we are looking for a triplet of numbers. Now, if there is no triplet, you can't do it. The problem, you just multiply the things on the inside because there's no triplet to kick out. You just multiply them together, and whatever the answer is, that's your radical, right? That's your answer. But this one does have a triplet, so I circled them. Now, what was the rule for the triplet?
Cross out 2, kick 1 out.
Yep, you always cross them out, all of them, and you kick one out. It doesn't matter the type of root. If it's square root, cube root, fourth root, whatever ones you circle that fit that stipulation, you cross them all out, and you kick one out. And when you kick it out, it's gone. So that 2 is on the outside. What's left on the inside?
Nothing.
Nothing. They're gone. There wasn't even a number left in there. So this radical isn't needed. That's your answer. It's just 2. Okay. Now, that problem. I've been showing it all week. That's why I want to do it. I want to remind you of those formulas. That is a perfect cube number. Questions? All right, you're gonna have to do that number today. Anytime they're nice numbers and they're in radical, you will have to simplify them. Now, if that was a decimal inside, because that will happen, I'll show you one of those examples today, you can just type it in your calculator and just give me the answer. So if it's a decimal, right away, just type it in, hit enter. You do need to find that square root button on your calculator. If you don't have a calculator, might be a good time that you want to think about investing into one. Because, you know, this year we need it for the rest of kind of the year. We'll need it in Algebra 2, Pre-Calc, Calc, Stats, whatever class you go into, Consumer Math, whatever class you decide to go into. It might be smart to have just a nice calculator on hand, okay? You know, don't go out and buy a super expensive one. $10 at Dollar General can get you one with these keys on it, scientific keys, okay? All right, are we good with that?
Yep.
All right, let's move on. That was my public service announcement for today. All right, now, when your problem actually works out to be a nice number, because today you will be dealing with square roots, the goal is to hopefully find a principal square, a nice clean number. One of my examples I'll give you today will have a clean number in it. If it doesn't, that's the ones you simplify like I did here. This one actually turned out to be a nice number, a principal root, but if it simplifies, you go to simplest form as far as you can. If it doesn't go very far, so be it. Just leave the answer and move on to the next problem. That's fine, you can leave them in radicals. You don't have to use your calculator. Questions? Okay, all right. Theorem 1, you already had this one Wednesday. You shouldn't be scrambling to write this one down. Okay, this is one you should have had. I believe it's already on the website and all that good stuff. Okay, the altitudes are drawn towards the hypotenuse of a right triangle. Then the two remaining triangles are similar to that and to the original one and each other. So this is what I'm talking about. You have a big right triangle where you have a right angle in there, angle C. When you draw the altitude straight down, it makes two small triangles, which are these two. I color-coded them. These triangles are related to each other and the original one. And what they say, they're similar. So they're proportional. So that means, what I talked about earlier this week, if you had an iPhone that had these triangles on it, and you like rotated them, you pinched and zoomed, eventually you can make each of those triangles the same size as each other. They could all be the same triangle if you pinched and zoomed enough, because they're all proportional. They're actually the same exact right triangle, they're just scales of each other. That's what I'm talking about when they're similar. That's why the formulas we're going to get today, the two formulas we have, they use this one. This is the reason why they work. Because all three triangles there, the big one and the two smaller resulting ones, all have two angles in them that are shared. All right, questions on the one that we did Wednesday? That was the theorem we had Wednesday. You sure already had that written down, correct? Okay, new one today. This one you need to write down. It's called the geometric mean of an altitude. So I'll let you write the words. The words are super complicated. The formula is not. So I'll let you write this down. The altitude drawn towards the hypotenuse of a right triangle separates the hypotenuse into two separate segments, two separate pieces. The length of that altitude is related to the two pieces that you just made. And I'll explain. I'll give you the picture. I'll give you the formula. Very simple. Okay, hopefully you have those words written down. Now, a lot of people, when they see it, they don't understand like what it's telling you. That's why I'm going to show you the formula here in a second. Now, the picture that goes with it is this one. It's the same picture I showed you a little bit ago. You have a big right triangle where these are the legs, and this is the big hypotenuse. But you're drawing, and that's the right angle, that's why these are the legs. When you draw this down, this is the altitude. It's the height. That's why they labeled it with an H. It's how tall that triangle is. What they're saying in this theorem is that that wall, this H, the height, is actually related to these two pieces on the bottom. It's related to X and Y on the bottom. Those three numbers are in perfect relationships because X and Y are parts of the hypotenuse. They're the two pieces that were resulting when I drew that H straight down. Okay, now, I want to give you the formula, just so you can see this. Now, the reason why the formula works is because all the triangles that are in there are similar. They're proportional. So we can set up proportions. Proportions, if you don't remember, what I talked about earlier this week, It's when you set two fractions equal to each other. Two separate fractions being equal. What this one is saying is that the height, the altitude, this height, I'm going to call it the altitude, is the geometric mean. That means the altitude can go in those two spots when you set your proportion. You repeat the same number in two spots. And then in the other two spots, you use the parts of the hypotenuse. So this is part 1 of the hypotenuse, and this is the part 2 of the hypotenuse. That's how you set that formula up. The altitude goes in those two locations, the parts of the bottom go in those two. So now, some people when they see that, they're like, okay, I kind of get it. Unless you see me like plug in numbers or these letters, it won't make sense. So let me plug in the letters. So what's the altitude letter? How tall is it? H. H and H go here, here. The same number, whatever it is. And then the parts of the bottom are X and Y. Those go here and here. One of the numbers will be missing. You solve for it. That's how easy that theorem is. This is what you do when you have a right triangle. You can find the parts given certain pieces. So what I'm going to do on the next slide is make this picture really big. I'm going to let you guys make up numbers, and we're going to solve for one of the sides that's missing, one of the parts out of those 3. Make sense? So you know how to use it. We're going to do 2 of them. Okay, we good? Does everyone have it written? Moving on. All right, here we go. Let's make this picture really big, and we'll put some numbers in so you know how to use it.
Wait, so what's X and Y? Is X and Y?
They're numbers. They're digits. They're the parts of the bottom. Yep, they're the lengths of those walls. So let's make up a height. Any height we want. Any label.
15.
15. Okay, I heard 15. Let's go 15 feet. Let's say it's 15 feet tall. Somebody give me the X.
5.
5. I heard 5. I like 5. 5 feet. Okay, what we're going to try to find is that little guy. The one that's missing. The other side. The other wall. So if you have these 3, where 2 of them are given and 1 isn't, you can go find the one that isn't. Okay, because I plug it in my formula. So the formula, if you don't have it, now if you didn't write that down, we put the altitude here and here, whatever that number is. You put the part of the hypotenuse here, and the other part here. The other part of the height. And this is the hypotenuse. Those are the parts of the hypotenuse. You broke it up into 2 pieces. So, let's plug the numbers in. What's my altitude? 15. So 15 and 15. Those go there and there, because the altitude goes in those 2 spots. The part of the bottom, 5. And the other part, Y. That goes there. That's it. Solved. That's a junior high math problem. How do you solve that in junior high?
Cancel out the 15s.
Fish. You don't cancel out the 15s. You cross multiply and divide them. So you start with the number above or below the Y. So that you always start with the number above or below it, wherever the Y is at, because you have 1 letter. You cross multiply and divide, and it looks like a fish. I know some of you said that. Looks like a goldfish I talked about earlier this week. Okay? Cross multiply. 15 times 15 divided by 5. And I think if you do this right, you should get 45.
And then there's Y.
And that is your Y length. So, what's the label on that? Feet. It's 45 feet long. That wall right there. That's why this is useful. So let me double check my math that it is correct. 15 times 15 divided by 5, I believe it is. I did my math right.
It is.
Okay, good. All right. We comfortable with the first one. That's the first out of 2 examples I want to give you with this. Now, same exact formula, I'm not changing it. I'm going to throw different numbers in there. So here we go. Same exact formula, hopefully that made sense. I'd like to give you at least 2 examples here so you know how to use it. Now, I'm missing the height. Height's gone. But I have this is a 4, so let's say this is 4 inches. And over here, this is 25 inches with a Y. So the whole bottom is 29 total, right? That's the whole hypotenuse. But we have 4 and 25. Let's plug in these numbers. So when we have my fractions, where does the H go?
That's the bottom and the top.
Bottom and top, diagonal from each other. H and H. That's the one number I'm missing. What are the other 2 numbers? 4 and 25. Okay, so how do you solve this? Now, this is different, right? You're looking at it and going, Ward, you have 2 letters there. What are you doing? You can still solve that. It's the same letter. It's not 2 different letters. It's H. So to solve this, you cross multiply. You multiply those together, you multiply these together, and you solve. h times h, and you take 4 times 5, or 4 times 25, I should say. Okay? All right, now what is h times h? Say it. Not 2h.
H squared.
H squared, thank you. Some people are saying it, some people weren't. It's h squared. It's not 2 h's. 2 h's, when you add them, I'm multiplying. So that's h squared. 4 times 25, that's perfect 100. Now, how do you get rid of the power 2? Somebody said it. Say it. What's the opposite of a square? Radical. Square root. I thought I heard it. The radical. The square root. That's where square roots come in. It's right there. Boom. You're seeing it right now. Now, you'd have to simplify that down. Now, the square root of 100 is a perfect number. What is it?
10.
10. It's perfectly 10. So, that is a perfect 10. That's this height. It would be 10 inches tall. It's a perfect number. Now, if it wasn't, let's say you didn't know that 100 had a perfect square. You could break it down like the rules I taught you all yesterday and this morning, and you could circle pairs and kick them out, and it turns out to be 10. Perfectly 10. Now, if this was a weird decimal, like let's say they give me decimals here. You multiply and you get a weird decimal, and you take the square root of a decimal. That's what you type in a calculator. If they're decimals, you keep them decimals, just type it in your calculator and give me the decimal you get. If it's not their perfect numbers, you have to simplify them. Don't use your calculator. The only reason why I know somebody might need a calculator on that problem is if you multiply these together and that was so big you couldn't figure out how to break it up, then you could actually use your calculator to figure out what goes in there, and then you could break it down into whatever you simplify it into. But I would like it to preferably to be in a radical but simplified. But if it's nice whole numbers, just write down the whole number. Okay, do we understand how this first problem works? I think it's easy. Like it's just a proportion. I did them when I was in like 4th, 5th grade. Maybe not that difficult, but I did them at some point. So I'm hoping that this makes sense to you. Now the radical stuff should be new. I'm betting on some of you haven't seen that unless you're in high school like algebra, where you've taken that. All right, now let's go to the second theorem today. This is our second and last theorem today. It has its own formula. So I said there's a second formula. So here you go. Here's your next theorem. 8.3. It's called the geometric mean, but it's for legs of a triangle, not the altitude. So let's write down the words. Okay, and again, when we do this problem, and I'll give you the formula, which is really easy again. I'll show you how to use it. We'll do 2 examples of it. And we'll move on to the last part that I want to discuss, the word geometric mean. Are we good? Got some people are sorry, it's fine. I'll give you the picture in a minute. It's the same picture as before. They threw a couple more labels in, because now we're not just talking about the altitude, now we're talking about the legs of the triangle, the original picture I gave you. I'll give you the picture here, but I'm not going to go on, because I know some of you are still scrambling to write. But if you are done, here's the picture. Same picture as before, but now, notice they didn't label the height, the altitude, because I don't care about the altitude on this one. But they did label the legs, they called them A and B, and they also labeled the bottom. What is the bottom called again?
The base.
The base, or, in this case, hypotenuse. And they label it with a C. That label wasn't there earlier. So now they labeled the legs and the hypotenuse, because those are the parts we're going to be looking at. Now notice they didn't keep the X and Y where they are. We are still going to use the X and Y in this formula. It's just not using the altitude this time. Now, again, the reason why, before I preface like why this works, is because all the triangles are similar to each other. They're proportional. That's why the proportion stuff works. So you can set up 2 fractions. Okay, I know some of you are still writing. Okay, we good? Does everyone have it? I know. Lang, you're still writing. Looks like we're good everywhere else. Okay, let's start with this one. Let's get to the formula. Now, we do have two legs on this picture. Which ones are my legs?
A and B.
A and B. Okay, so these are the legs. I would like you to pick one of them right now.
A.
A. Okay, we're going to use A. Boom, we're using A. What this formula says, once you pick your leg, so if you need to like rotate your book today, like if the pictures don't look like this, you can rotate them so it does. You have to pick one of the legs. That leg, what they say here, the leg is the geometric mean. So when you set up your proportion, the leg you choose is going to go here and here. That's where the altitude was earlier. Now we're using the leg of it. And now what this also says, the leg is the geometric mean between the part of the hypotenuse, the part of the bottom, that is closest to the leg you chose, the adjacent leg, or the adjacent part. So what letter, X or Y, is closest to A?
X.
Say it again. Y, thank you. Y is closest to the letter A. And then, I should say, if I'm putting into words, this would be the part of the hypotenuse that's closest, so that would be your Y, and I'll put that here in a minute. And what is the whole bottom called? C, or, what's the other word? Hypotenuse. That goes here. The whole bottom goes there. So now, give you the letters, because I know some people like to see the letters where they need to go. A and A go here and here. That's A's. The part of the hypotenuse that's closest to the A is the Y, and then the whole bottom, what you guys were saying, was C. That was the whole bottom. That's your formula. Make sense? Now, I said there was a second formula to this. Like there's another way, because you guys picked A first, correct? You could have picked B. You just had to pick one of the legs. So if you picked the B instead, not A, the formula will be slightly different. So if you picked B, B is the leg, so that goes here and here. What's the part closest to B? X, and the whole bottom is C. That's the difference. Okay, so let's do an example. So I'm going to blow this picture up really big, and we're going to try an example with numbers in it, and we're actually going to do two of these. Okay, and again, I'll put the formula back on the board here in a minute, because I'm just going to make this picture really, really big. Alright, here we go. Okay, so let's fill in some numbers. So somebody give me a number for B.
12.
12? Okay, I'm going to use 12. 12, let's go 12 inches. Let's go a number for X. Now, X does have to be smaller than B. I'll explain that Monday. It does have to be smaller than B.
3.
3? Okay, let's go 3 inches. And now what we're going to find is we're going to find the whole bottom. We're going to find the whole bottom. Because again, these three numbers have to be in relationship to each other. The leg, the part closest to the leg, and then the whole bottom. That's how you use this formula. Notice I'm not trying to find the height, the altitude, because I don't have that Y. I'm not trying to find A, because I don't have the number closest to it. So this is the 3, and I can find C in this case. So how I set up my formula? So I'm going to set up my fraction here. The leg that I have is 12 and 12. The part closest to the leg was 3. And the part I'm trying to find is C. That would be the whole bottom. That's the hypotenuse. Now, when I find C, what should you expect? Is it going to be a big number or small?
Big.
Big. It's the hypotenuse. It's the biggest wall. You can see it's clearly huge. It's going to be bigger than 12. It's bigger than 3, obviously, but it's huge. It's big. I'm expecting it to be big. All right, so let's go through the math here. So when you saw this, again, it just has one letter, so you're going to start with the number above or below it, cross, multiply, and divide. It looks like a goldfish again. If you like the goldfish, here you go. Here's your fish. All right. So you're going to cross, multiply 12 times 12, and then you divide by 3. And what do you get? 48. Now, what's the label on that? Inches. So this bottom is 48 inches. And again, I said it was going to be big. It's definitely bigger than the other two. Now, here's the cool part. Once you have that, I can pretty much find the rest of that triangle. All the rest of the walls. Because what should X and Y add up to be?
48.
C, 48. So that means if this is 3, that Y has to be a 45. This has to be 45 inches. Because duh, these have to add together to get 48. It's the whole bottom. You can add them together. So now I know the 45 there, and now that I know that, I can go after A. And I could go after the height as well, because I could find the altitude, because I can use these two parts, the two parts on the bottom, the formula I showed you earlier. the first formula I showed you. So we can actually solve the rest of this thing. In fact, I'm going to go after A right now. A is going to use those two numbers to find A. So again, if I set up my formula, A goes here and here, because that's your geometric mean. So the legs go there. The part closest to your leg and the whole bottom. So now, multiplying this, cross multiply, so I get A squared equals 48 times 45, which is huge. I can't even imagine what that number is. Okay? Does somebody actually know that number?
2,116.
2,116?
16.
60? Oh my goodness. All right, 2,160, and that's A squared. And then how do I solve again? Square root. Now, you're probably thinking, okay, this is where you probably need a calculator to like break this down. I'm just going to break it down right now for you. I know that in 2,160, a 5, a 9, a 6, and an 8 go into it. You're probably thinking, where the heck did you know that? Because what were the two numbers I multiplied? 48 and 45. You can just split those up. So I can split up really fast in my head. So then this makes 5, right? This makes 3 times 3. This makes 2 times 3. This makes 2 times 2 times 2, because that's 8. Right, 2 times 2 times 2. So I broke up 6, broke up 8, broke up 9, broke up 5. And now I look for pairs. I have a pair of 3s. I have a pair of 2s. I have actually another pair of 2s. So there's a lot of stuff, and you can kick stuff out and keep stuff in there. So there's a lot of stuff there. In fact, the only thing that would be left on the inside would be a 5 and a 3. Because everything else was in pairs. But again, that's the type of math I'd want. Okay. Questions on what I did there to find A? And again, leave it a square root. It's fine. You don't need to type it in your calculator. The only reason why I did that is just to show you the level of that. Now, again, do you have to do that in your problems? Yeah. There's homework problems that will ask you to find legs. And they'll give you parts, you might have to go find another part. Okay, last slide today. Hopefully that made sense to you. And again, I am recording this, so if you need to watch this like 50 times over to make sure you caught all that. I will have 2 videos on the website for this particular section today. One of which is you watching me up here right now because I'm recording your class. The second of which, I did this all earlier today, but I did it on an iPad with not me saying on the board. I just did it on an iPad so you could see it without me saying in the way, and you can hardly see it. Like you can just zoom in all you want. So I did it on an iPad too because I know this stuff is kind of hard. Okay, so let's go to the last slide today. I want to talk about the word geometric mean. Geometric mean is when you do a proportion. That's what we've been doing the whole day. We've been setting up proportions. When they said, like on that theorem 8.1, it said that, theorem 8.2, it said that the altitude was the geometric mean. The geometric mean are the numbers that are diagonal. That's why we had to put the altitude here and here. Or when we did the leg one, 8.3, the legs had to go here and here because those are the geometric means. The geometric mean, the definition is different than algebra class. A mean in algebra class is when, let's say you went bowling and you scored a 5 on the first bowling attempt and you scored a 20 on the next bowling attempt. So you're really bad at bowling, like you're terrible. Okay? How you find an average in or what they call the mean in algebra 1, you add them together and you divide by 2. And you get like 12.5 as your average. That's a terrible bowling average. Right? That is different than the geometric mean. The geometric mean is when I do proportions. So, to do the same thing, it would be using a radical. I'll show you this here in a second. To do a geometric mean with the same numbers means you have to draw a triangle with an altitude, this is your height, where the 5 and 20 are the lengths of the walls on the bottom. This is how you find a geometric mean, not an algebraic mean. Algebra is when you add the numbers together and you divide. On this one, you set up the height. This is the first formula we use today. The height goes here and here. The 5 and 20 go here and here. And to solve, you cross multiply. H squared equals 5 times 20, which is what, 100?
Yes.
And then you take the radical to the other side. And what is the square root of 100?
10.
It's 10. We did that one earlier. In fact, what you're actually looking at here, what you just saw me do, other than this stupid one, this is your first homework problem. It's problem number 1. I just gave you the answer.
Nice.
They ask you to find the geometric mean. They just give you the numbers. You do not have to draw the picture. You can just set it up in your formula because you know where the numbers need to go. And you have to find the geometric mean between them. Now, if it doesn't work out to be a nice, pretty number, just leave it a square root. Just simplify it. You don't need to type it in your calculator. So that's your first problem. That is problem number 1 in your homework. It's right there. You just did it. They say find the geometric mean between these two numbers, and that's all they give you. So you just have to set it up in that little proportion solve. The rest of the problems you have in your homework, they always give the triangles and they have you find the missing walls. So you will only need a calculator. I think this homework is ridiculously easy. It's all proportion stuff you did in junior high. It just now you have to know how to set it up.
No, we didn't do anything in junior.
Alright, well, you did it now in high school. Alright, okay, alright.
Okay.
Here you go.
What?
Here's your homework.
I should have copied. Here,
Okay, this homework is due Wednesday. 1 through 3, 5 and 6, 8 through 10, 18 through 20. There's not a lot. Some of these problems, like these are geometric mean ones. I think 8 through 10 are geometric means. The rest of these problems are pictures. And they want you to find a missing wall. Pretty easy. But you have to know your two formulas. Okay, again, I will post these videos probably tonight. Probably really late tonight. I'll get back probably about midnight or 1 tonight
Are
for
you
basketball.
serious?
I'll post them online.
1 o'clock.
Midnight probably. I'd expect midnight. It's about a 2-hour bus ride, so.
Or two.
North Union. So just kind of what time the boys' game gets over. It's over at 9, 9:30. Yeah, we'll be back before midnight. If it's after that, it'll be a late. But I'll try to post them tonight or tomorrow morning anyway. But I'll have 2 videos. I know that seems weird, but some people just need to watch these videos so you know how to do it. Okay, but there's your homework. It's written on the board. Okay, you have the rest of class day to work.
Why?